Welcome back to our Python Quickstart tutorial.
In this video, we will explore how to perform basic matrix and vector operations using the array and matrix classes provided by NumPy.
So let's look a little bit deeper into it. And at that point, I'm pretty much hopping into the array class because the array class is something that I feel is missing in things like MATLAB. I have two vectors, u and v. These are 1D objects. So strictly speaking, from the index, first, second, and third, or index 0, 1, and 2 in the Python logic, it doesn't matter if these are column or rows. In MATLAB, it does because it doesn't have that data type. It uses that 1 by n or n times 1 matrix representation. So in this case, if I do my two vectors here, u and v, I have my vectors, and hey, it looked like lists. That's the nice part. But now, remember, if I worked with lists, the plus operator combined the lists, while here, the plus operator creates another array object that is the proper vector operation. The other part that was missing in the list type is a dot product. How do I compute a dot product between vectors? One way is I say, hey, NumPy, use your dot product function and give me the dot product between the vectors u and v. Hey, that's the standard dot product u and v, 1 times 4 plus 1 times 4 plus 2 times 5 plus 3 times 16, 32. The other way is you can use member methods. So u is a vector. A vector knows how to dot itself with, and for those of you who did a bit more tensor analysis, you will know that you can dot with a vector to create a scalar, with a second order tensor to create a vector, with a third order tensor to create a second order tensor, and so forth. So this method is a bit more powerful in general, and say, hey, you dot yourself with a vector v, or v dot yourself with a vector u, and nice, we see that u dot v and v dot u is the same. We know that from vector calculus. And the thing to make it really interesting is, so what is u add as a matrix product? That's two first order objects. That's something that's nothing equivalent like to this in MATLAB. That's another way vector gives a scalar. The last one is possibly the most obscure one, and I would normally not use that, but who knows? Maybe you like it and you want to use it. So now comes the stuff for the tensor geeks. That's the outer product. Yeah, u outer v or u tensor v, that takes two vectors and combines them into a second order tensor. Some of the MATLAB people know that as the wrong dot product. So if you have two vectors and you want the dot product, you say u prime times v, and you get a matrix instead of a scalar. That basically means you computed the outer product. And since that's a different object, I think the closest in the logic is this. The dot product is perform a dot product or perform an outer product between two array objects. And if we do this, it does the proper operation. I've given for you here a little bit of information how that's defined. Again, unless you're working in the field where these operations make sense, you can, and you may skip that section. But if you ever need it, remember to look into the NumPy manual, because you have all the tensor operations and way more available in the array class. So whenever you're dealing with tensor stuff, the array class is your thing to do it. I just want to complete this by saying, What if you don't want to switch? You stay with the matrix class because you come from MATLAB. I do the same exercise. Now I define U and V as two matrices. The big difference is if you look here. I've done it as I've defined them as row vectors here. Then we get a 1/3 vector, or, and this is if you look at it from this versus that form defining, this is a list of 3 rows, 1 element each, that would define 2 column vectors. So right now we have our column vectors. I can do plus, I get the normal operation. The dot product is now as peculiar as in MATLAB. You need to have that transposed. That's how you would do it in MATLAB. U prime times V, and careful, MATLAB is hiding that from you, that the result is a 1/1 matrix. If you get a 1/1 matrix in MATLAB, it says it's a number, and it gives you a number, but in reality, it's a 1/1 matrix with the value of the dot product. And this can become critical when you do Python, because it's really picky that it stays a matrix and isn't converted to a floating point. It's the 0, element of this, that's the number. If you use the dot product function, it's actually not defined the way it should, because the standard dot product would do a matrix multiplication. So be careful. And if you do, on the other end, the wrong product, so you transpose the second one, then you get the outer product the way we're familiar with it.